I'm not very good at this, but maybe with a little practice, I could tell myself to relax it. Will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake. It's okay, it's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay, it's okay. Whoopsies, help me look, see I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard to follow before it's too late. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard to follow before it's too dark. Wake up, my love, please don't give up on me.
What's up, sup, you guys? My God, I kind of missed the timing on that a little bit. How's it going? Are you excited? I'm excited. Today is the start of 100 days of Rootkit, where we're going to be teaching y'all for 100 days how to become a certified programmer. All right, let's first verify everything's good. Mods, can you guys hear me? Does it sound fine? I should probably go with a faster chat over here. All good. Sweet, sweet, sweet. Let's bring this up right here. All right. Awesome. Nice for everyone here to be here joining us today. Epic, epic, epic. For those who will watch afterwards, thanks for watching. Now, this is going to be like no class you've ever had before. This is going to be like some teen-rated stuff. We're going to be cussing every once in a while. So if you're uncomfortable with that, sorry. But that's how life is, all right? Now, unlike any other class educational institution you've ever been to, we're going to actually listen to you. We're going to mold everything that we talk about and teach around you and how you guys are learning and soaking up this information. At first, we're going to have chat. It's open to everyone, so anyone can chat, talk. If we start getting a little full, then we'll have to go to supporters only. So that would be people that are subscribed to our Patreon or subscribed to our Discord Premium. Please, for the love of God, do not donate bits. Do not do any type of paid subscription on Twitch or on YouTube, any of that stuff. Subscribe and follow us, though. All right, the free stuff. Do that. If you do want to donate and help us out, then go to our stream donation link. That's the little bar up there at the top. So you can help fill that up or become a Patreon member. All right, that's the best way to support us. We don't get any cuts that are taken away. If you do the other methods, they'll take a percentage, but if you donate, 100% of that will come to us. We are a non-profit. So let's talk a little bit more first about Rootkit. We're a registered non-profit organization here in the US, and our mission is to educate and certify individuals in the computer science space. So that's what we're doing here today. We're here to just educate y'all for 100 days straight. Financially, it makes absolutely no sense. We're losing lots and lots of cash and money, and it hurts a lot. But, you know, I'm not that good at business, I guess. So here we are. So let's move forward. How are y'all's days today? Feel free to chat in the chat. I will be interacting with you guys all the time. As we're going through things, please ask questions all of the time. Our theme for the 100 days is going to be oopsie, because we want you guys to fail, make mistakes. Look at that. We got another follower. Thanks for the follow, Kawaii Siren. That's your name now, all right? I don't know if I pronounced it right, but that's it. Oh, God. Taylor, you don't get a shout out, all right? All right, so oopsies. We want you guys to fail. You need to fail. You need to make mistakes. I want you to be the biggest failure, just like me, all right? You don't get anywhere in life, in any job, if you're not a failure at first. So get used to failing. It's okay. So we talked about Rootkit. All right. We're going from 0 to here, all right? You don't need to know anything about programming. You can barely understand how to use a computer. That's okay. Step 1, all right? You guys have a computer, or else you wouldn't really be watching unless you're on a mobile device. On this computer, it might look something like this, where you have your desktop and your taskbar at the bottom. The first thing I need you guys to do, because now you're a pro dev, right? Pro devs, first step, right click on this bar right here. We got to get rid of some cancer that's on this screen right now. I need you guys to uncheck task view button. I need you to uncheck the show Cortana button, And I need you to go to search, and I need you to hide that. For the love of God, please get rid of all that crap. You will give me cancer. I will have an aneurysm on stream if I ever see that, if I'm helping one of you guys out. Alright, you don't need them. They're just a waste of space. It makes it all look ugly. But then you might be asking, oh, Elijah, how do I search for stuff now? Look, just press the Windows key and start typing, alright? That's how you can search on Windows. You don't need the bar or anything like that. It takes up too much extra space. Alright, let's see here. Taking a look at the chat, see if there's anything there. Alright, so let's move on to the next item. So, this is your guys' computer. Awesome. Your computer can do lots of cool things like access the internet. As long as you're able to access the internet, you can become a programmer, right? You don't need a high-end computer. You don't need good specs. You don't need any of that jazz, all right? And I'm going to show you how you can become a programmer no matter your range of income or what type of computer you have. If you have a Chromebook, doesn't matter. We're going to teach you everything so you can become certified no matter the device. All right. So before we move forward, if you haven't already, make sure you subscribe, make sure you follow on Twitch, and you join our Discord. Also, again, you can go to this link here. I'm going to put this, I guess, in... Why is it not posting there? I'm going to put this in both of the chats. This will be in the description if you're watching later on. This is where we're raising money. This will fill up the bar. When you donate on here, we have some items that you are able to get depending on your donation tier. So make sure you get yourself some merch. Also, pop-ups will happen. Let's see here. The bars will fill up, and we have a bunch of goals on our goal posts, including shaving my head and my beard. So if you get disgusted with this beard and you want to see it go away, make sure you donate. Tell your friends, have them donate, so you can get this beard shaven off. All right, look at this thing. It's so beautiful. You don't want to do it. Don't donate. Don't help with this. This is this is a scam. Don't do it. Leave my beard alone. All right. So we have that, which is for paid stuff because you have to give money. If you go to our website, and we push this out a lot on Discord, on our blog, this is the free giveaway. So if you're super poor, hey, still tell your friends and family about this, but you can come on here and you can participate for free. And we're going to be giving away stuff every week, merchandise for free every week on here. So we got everyone covered. All right. Let's see. Anything else? Any questions on that stuff? If you guys do have questions, just go ahead and post them into the chat. Alrighty, let's see here. Should we get some nice chill lo-fi in the background while we move forward? Let's go ahead and try that. If it gets too distracting, I might remove it. Y'all let me know if it's too distracting or annoying. Alright, so let's see here. Alright, so I guess if you're here, hold on, we got a question. Will you be streaming the same time every day? Kind of, yes. Depends. First of all, it depends on you guys and what you guys want. Oh my god! Oh, holy shit. Oh my god. Thanks for that donation. Holy crap, the bar has gone up. That's some loud crap on my end. I don't know if you guys can hear that. Oh, who was that? Saitama. I'm gonna go with that one. Thanks for the sub or donation for $10. Alright. Epic, epic, epic. We're already getting this train going along and I haven't really gone that deep yet, alright? Let me get a little deep first, alright? Alright, computer science. Let's talk about computer science a little bit. Because a lot of you guys want to get into that realm and either you don't understand how big it is or you don't understand the depth that it goes to. So computer science is literally touches just about everything that you do today, from your phones to your cars to your tractors if you're working on a farm, to even lights that get displayed around the cities and towns. If you want to be a programmer, you can literally do it for just about anything that's potentially strikes your passion. Maybe it's marine stuff, maybe it's machine learning, maybe it's bringing the world down and watching everything burn as a hacker. You can totally do anything that you put your mind to. And that's the biggest thing you need and the biggest requirement for being a good programmer, right? We're going to go with good programmer right now. You can be a programmer without this, but be a good programmer, you need creativity, you need imagination, you need passion, all right? As long as you have those things driving you, you're going to be an amazing, great programmer, no matter how fast you learn, etc., etc. Programming is easy, all right? Anyone can learn programming, anyone can be a great programmer, but only those that have creativity and will and determination will be like truly, truly great. If you just want to be a programmer and collect a paycheck, hey, you can totally do that. Most of the people in the programming field, that's what they do. They're just there to get their paycheck and move forward, but that's the big determining factor between the two. So, computer science. What is computer science in general? Computer science is a term that's interchangeably used with computer engineering a lot of the time. You can say either one, you'll be just fine. There is a slight difference now. Science is usually more of the scientific researching role of maybe how to do something or make something optimized. Engineering is now kind of the term for programmers. So you'll see that more and more when you're applying for jobs and so forth, but engineering technically is the more proper term, but we're going to say computer science because that's what everyone still uses. A lot of terms in computer science are pretty much made up year to year. So terms like this, you'll hear DevOps, Sec DevOps, just various terms like that. They're recently created terms that really, like, can you guess what that means? I can't. Well, I know what it means, but the point is, new terms for the computer science field are made all the time. So if you don't know what they mean, don't worry. Most programmers in the field don't know what it means anyways. All right, so let's go over some computer science jobs. Computer science jobs. Look at this. You can Google along with me because we're both going to be Googling. I'm not going to sit here and memorize every single one of these jobs or topics that we're going over to the T. So we're going to use our best buddy Google. All right. So there's web devs. This is kind of redundant, but there's web developers. So people that make websites. Also, you could be making the back end of the website. So that's usually broken into 2 to 3 different categories. So first is called front-end devs. Those are the people making everything that you see visibly. There's back-end devs. Those are the people making everything you can't see behind the scenes. And then there's full-stack devs. Those are the gods. They can do both. There's UX designers. UX stands for user experience. Sorry, I kind of blanked there. User experience. So their whole thing is they're going to sit there and just focus on how do we make the best user experience ever. Because there's only one company that has nailed down user experience still to this day, and that would be Apple. It's just not even a competition anywhere else. Apple has solid UX. There's mobile app devs, which is kind of convoluted with front end or web devs now, because a lot of web devs can deploy their applications as websites or as apps. So you don't need to be a quote unquote mobile app dev to be a mobile app dev, pretty much. There's IT, so people that work on systems, so putting computers together, laying cable down, connecting everything together, making sure everything is right. And if everything is not right, that's where you call them up on the phone and say, hey, help me with my computer here. And then they tell you, have you turned it off and on again? And that usually solves the issue. So they have a great job because 90% of it is telling people to turn on or off and on their stuff again. There's SEC analysts. So these guys will be looking through information and logs and trying to make sure everything is safe. There's system architects, which are pretty much exactly like IT people. There's machine learning jobs. So that's for making all your cool machine learning stuff. There's hardware engineers, which we aren't really going to get into right now. There's video game devs. God, this list kind of sucks. There's video game devs, and then there's kernel developers, so people are making your kernels. I guess software engineer is a generic term, but it's usually for like computer applications. So there's a bunch of jobs like that are available. Any questions right now? Any questions in the chat? Let me go to the multi-stream here. I guess I should bring it up there, right here. So the languages, the programming languages, which we'll get into a little bit here, don't worry about them. Don't worry about what language you should learn for what job, etc., etc. Because at the end of the day, it doesn't matter. As long as you learn one language, you pretty much know all of the languages. They are all pretty much exactly the same. This is not like Korean versus Chinese versus English, all right, where everything is completely different. It's going to take you years and years to master each one. No. You learn one programming language, you now pretty much know all of the programming languages, all right? You'll see more as we get into that stuff. Yep, reverse engineering is jobs that you can definitely do. Let's see here. I mean, like I said before, if you want to work for farming companies, there's plenty of tech jobs in the farming industry for you to help make software for all of everything farming related. They even have the up-and-coming agricultural stuff that's like the smart farms with robots that go around picking all the plants, automatically watering them, etc., etc. There is just an unlimited amount. And then there's the financial sector of jobs that you can do. There are a lot of jobs in the computer science field that you can do. So my recommendation is find something that you want to do and pursue it, all right? You don't have to settle if you don't want to. Another thing, if you get certified, we will personally help you and guarantee you to a job position somewhere. It may not be your dream job, but sometimes you have to take an entry-level job just to, start building the years of experience before you can go on and do greater and better things. But we will help you. Asterisk, this is like 100% guaranteed for U.S. individuals. If you're not in the U.S., we will still 100% help you. But if you are in the U.S., we can guarantee you a job if you get our computer science certificate. Now, going into this a little bit more, this is going to be a computer science course. This is not just a rip-off coding boot camp where we charge $20,000 for you to go through for like 10 weeks and then give you a little piece of paper at the end of it. This is not that. This is better and more than that. This is equivalent to a 4-year computer science degree program at a prestigious university. We are going to teach you everything they teach you at high-end colleges right here in 100 days, because they just egg you on for 100 days and then steal, if you're in the US, $100K of your money. Don't get scammed. Get certified. Let's get you a job. All right, let's see what's the next thing on here. So we went over computer science. Jobs that you can get in the computer science field. We went over that a little bit. Now, let's check the chat real quick. If you can make some simple shell loops, you can do in any lang. They just have their own little twists on syntax. Exactly. That's pretty much it, and we'll get into that more here in a bit. So, what are the limits of a programmer, or when you're learning programming? There are no limits. If you can think of it and dream it, you can create it. anything. You can literally make it. The only limits you may run into might be financial limits, because if you need certain hardware, I mean, if you don't have the money, then you can't buy it. And then languages. Some languages may have limitations compared to others. So you may want to, or you may have to learn a different language to do exactly what you're trying to do. But at the end of the day, you think of it, you can do it. You know, you imagine it, you can create it. There are no limits to programmers. What does it require to be a programmer? Literally nothing, just a computer internet connection, and we'll show you guys that here in a second. Do I need to get a degree to get a programming job? No, asterisks. Most programming jobs you can get with just our certification. There are some jobs, typically in regards to your local government, so here in the US, where the government jobs will not even look at your application unless you have a degree. They're really, really delayed. I mean, the government's always delayed and behind on everything, and they always suck. So you don't need a degree for most programming jobs. Look, I don't have a degree. I've gotten any job I've ever wanted and more. All right, you don't need one. Just our certificate will be enough, unless you want to do gov stuff. But there's workarounds through that via contracting companies. All right, why should I get your cert? Again, we kind of covered this. Our cert lets you skip college completely. If you're in college right now, stay in college, get our cert, and then apply to jobs before you're even out of college. We can get you a job and then you can leave college early, all right? There's no need to go to college. There's no need to waste that time. There's no need, if you're in the US, to use all that money. Don't go to college, all right? That's the big thing. You can completely skip it. If you're in high school right now, get certified and we'll get you a job right outside of college, all right? And this isn't some crappy paying minimum wage job. This is a full-on dev job with dev salary and dev benefits. All right. Next, our first thing is how to Google correctly. So are there any questions right now before we move forward? I go to Harvard, kind of facts at times. Yep, you'll see it all the time. Elon Musk will hire you without a high school diploma. Yeah, any of Elon Musk's companies will hire you without a diploma. Most companies will hire you without a diploma. So Google, Amazon, etc., etc. Just know there's kind of a catch. A lot of them want senior or mid-level devs, which means they expect you to have a couple years of experience. So you kind of get stuck initially in this loop of, I need a job to work at where I want to work, but to get the job where I want to work, I have to get a shittier job first. But a lot of people don't want entry-level developers, and this is a struggle that a lot of people that are in college also hit, is a lot of people don't want entry-level developers. Why? Why don't they want entry-level developers? It's because college produces terrible devs. No one wants entry-level devs because most college graduates are absolutely useless for the jobs that they're placed in. And it takes usually an additional 3 to 6 months just to train them up to do the job that they want you to do. So here at Rootkit, what we certify you in is at a standard above what colleges will teach you. And it's exactly what businesses want right now. We are constantly in communication with companies all around the world and what their requirements are, and we make sure that we hit all of those requirements strong. The only thing that I would recommend more than just our normal computer science cert would be the advanced computer science cert, which is a couple extra things that will 100% nail you a job quicker and for more money. Usually, if you're in the US, you could probably squeak out $20,000 more on your salary. It's a pretty big jump. Would you go to college if you got paid the same as a job or more? No. College, I find, is mind-numbing. It's boring. It's mind-numbing. It's just a terrible experience. I sucked at school. I was terrible at school. If you suck at school, look, you're perfect for becoming a programmer. All right, not high-end grades, not at all, not by a long shot, barely like passing like some classes. It does not matter. To be a programmer, it does not matter. All it matters is making sure we hit those things that make you passionate, and then you can learn. Anyone can become a programmer. All right, let's go ahead and move on here. I see a lot of things coming through the chat, but we're going to go and move on. So, before we start programming or anything, we're going to be covering the foundations. We're going to hit on some programming here and there over the next couple weeks, but really, we're going to be starting out and building your foundation. Some of you might view it as the more boring part. Look, I'm going to try my hardest to make it not boring. And if you're bored, you put in that chat and say, hey, I'm bored, be funnier. And you know what? I'll try, all right? I'll try my best to be funnier. But we have to go through the foundations, because if you're going to be a good dev, you need to have a solid foundation, all right? If you're going to build a house, you're not going to build it right on the sandy beach, all right? You're going to lay down some nice cement first, all right? Make a nice little block there. And then once you got a sturdy foundation, that's when you'll build the house. So that way it will last longer, all right? Be better for everyone. So, foundational step number 1. How do you Google things? You guys are terrible, terrible, terrible at Googling stuff, all right? And I think it's kind of funny that we're in a modern age where you need to use the internet and Google, but schools kind of fail you guys through high school, elementary school, college. They don't really go over how to Google things correctly just for you to find resources. So we're gonna start that out right now. How to properly Google as a pro dev, all right? Don't do that. Don't do what I just did, all right? That's step number 1, all right? Let's just go to google.com. All right, we're at google.com. How do you Google stuff? We're going to be going over and talking about a lot of different programming languages. Don't worry and get caught up on which one's best at which. This lesson is just about your syntax, or basically syntax is a fancy way of how do you put things where, or where do you put things where. So first is the program language's name. This is not a programming language, but we're going to go with it for now because we're talking English. So that is the language. All right. So you will first put the language that you're using first, and then after that, you want to be kind of direct on what you want to do. So let's say you want to add numbers together. So I'm going to do Python, which is a programming language. All right. Add 2 numbers. I'm not asking particularly a question. I'm kind of just dictating like, hey, Google, add 2 numbers. Like, how do I add 2 numbers together? When you do this type of syntax, you usually will get the result that you want immediately on the first link. All right, so let's check out this first link here. And look at that. We get a great example of how to add 2 numbers. No, I don't want to subscribe to your crap. The big, awesome links that you'll see a lot is going to be W3 Schools Programmatics with the Z at the end.com, and it's not here, but Stack Overflow. Those are both solid sites. Definitely you can go to those ones. But this is kind of the syntax you want to go for. Always put the programming language first and then space and kind of just dictate what you want. If you have an error, paste the error right there, all right? Don't do any weird question asking or anything like that. That is how you get the best results immediately. Now, this is not school. This is not college. This is real life. And in real life, you cheat, all right? You become a cheat, you steal, you grab whatever you need. In the programming field, we're all thieves. And you need to become a thief also, right? Not a thief in the sense that you're going to go to prison, but copy things, look things up. You need to figure out something like how to read a file in Python, read file. Bam, click that. Okay, here's the code. Copy it, put in your into your code base. Take stuff. That's all the real world is taking a bunch of things that have already been made or exist and meshing them together. You do not get negative points. It does not hurt against you. Do it. I'm telling you and I'm encouraging you to do it this way. Google things, steal code. Now make sure if you're doing taking code from GitHub and they have a license that requires you to refer to them, make sure you refer to them and give people credit when credit's due. But copy, steal, take all the code. It is good. It is normal. Do it. All right. This is not college. This is not high school where you have to make everything originally. There is no originality. Everything's probably already been done that you want to do. All right. Now, useful resources. I'm going to put this in here, and then I'm also going to put it in the chats. Now I see there was a question. Let me answer that. I feel like my stream stuff isn't relaying the questions from YouTube correctly, but let's check that out real quick. When do you learn to make the things, though? I'm guessing for programming. When do you learn to make the things, though? That will be starting now. Everything that we're going to be teaching is going to be forming that foundation. Now, useful links. I posted this in the Twitch and the YouTube chat. If you go here, you'll see our computer science roadmap. Go and click on that. The main README here has a bunch of useful links, and this is pretty much what we're going through one by one, each one of these items. This is the foundational items we're going to learn first, and after that, let me zoom in here. Foundational items we're going to go through, and then after that, we're going to then get into programming languages. Well, throughout the whole thing, we're going to be doing programming languages, but after foundations is really where we're going to get into it. Now, at the bottom, lots of free resources for you guys to use. Free websites, free YouTube channels, and some mixed and paid content for you guys to utilize to help continue your education through this. Highly recommend you guys using that. And then you can click on any of these items and see what we're going to be going through, and we'll get more into that here in a second. All right, back to my notes here. Yep, we already talked about that stuff. Sweet. All right, we're about to jump into computers and internals here. We're going to talk about that a little bit. Are there any questions before we start diving in? Actually, we'll get into how you can program from a Chromebook first. Any questions here? All right, let's see. Forking, he's not stealing. All right, looks like there's no questions, so let's get some water. Again, if you have questions at any time, throw them in the chat. If you're in the supporter chat at Discord, just ping me at any time if you have questions. If you're a mod and someone asked a question and I totally skipped over it, ping me in the supporter chat also. To get my attention, because I got like 50 chats open right now. All right, so let's start with something pretty basic, which some of you guys probably already know, but we're going to go over it anyways, just to make sure that we're all on the same page, because that's the most important thing for us. Why would a company want someone who is a basic dev? Is that what you're asking, Taylor? I'm gonna wait for his response there and just move. Oh, yeah. Why would a company want someone who is a basic dev? The most beneficial thing for someone that's a brand new basic dev, you have no alliances. So if they are able to hire you and kind of take you under their wing, most likely you'll stay there longer and will save them money in the long term, and it's just going to be mutually beneficial for both of you guys because they'll be training you and you'll stick with them for a long time. The thing is, for Silicon Valley jobs, they don't really care too much about that anymore because of the high turnover rate. It's kind of changing right now, but it's infamous, especially with startups and all of Elon Musk's companies, is they have usually a decent turnover rate, so devs will leave because of the long working hours. You're working some days, well, most days, 12 plus hours on things, so you don't really have a social life afterwards, which if you're single might be fine, but if you have a family, might not be the move for you. All right, so what is a computer? Great question. Anyone in chat want to answer that? We are keeping track of when I ask questions, people in chat that answer them correctly, we are keeping track of that. So there might be some benefits for doing that. So make sure you're interacting and answering those questions. All right. So what is a computer? Well, let's Google it. All right. We're going to be Googling a lot. Why? Because I don't know anything. No, that's not the real answer, but because I want you guys to be comfortable with Googling. You know, it doesn't matter the skill level that you're at, you're always going to use Google, even for the smallest, dumbest things. All right, let's see what Wikipedia says. A computer that is a machine that can be programmed to carry out a sequence of math or logical operations automatically. Computer is a machine, all right? When we look at images of a computer, all right, you'll see usually the predominant picture in these is a monitor. This is a great example. It's just a monitor and a keyboard. Neither of these are your computer, all right? This box right here, the box right there that's labeled system unit, that is your computer. Oh God. The other thing, the screen, is referred to as a monitor, right? So when we're talking about your computer, we're talking about this box. Also, it's referred to as your box. So if you ever are talking to someone that's talking about, you know, their box or the specs on their box, or they need to build a new box, that's what they're referring to, is the box where your all your hardware components are put into. So I said a term there, hardware components. So let's talk about that a little bit. Who knows in chat what's the difference between hardware and software? I'll give you guys a second to answer that. Hardware is physical and software isn't. 100% correct. That is the easiest way to understand it, is hardware is physical. If you can take your hand and touch it onto something, that is hardware. If you can't ever physically touch that thing, it is software. So programmers work in the software realm. We work in the imaginary, in the things that you aren't physical, you can't touch them. But man, they'll touch your soul, all right? All right. It's almost like God mode is turned on because nothing exists until you will it to exist. That's software, all right? Hardware, it has to exist first, and you have to make it into something else in order for it to function. We're going to be dealing with software, all right? Let's see what Google has to say about all this hardware. Computer hardware includes the physical parts of a computer, such as the case, the CPU, memory, monitor, mouse, keyboard, and data storage, graphics cards, sound cards, motherboard, speakers, etc., etc., etc. All of that is hardware. Your phone, hardware, right? The things you can't touch on your phone, software. All right, I don't need no sarcasm, all right? Like, oh, the screen, I can touch the screen and the things here. No, you can't. You're touching glass, all right? It's not. You're not actually touching the software, right? All right. Software. Software is a set of computer programs and associated documentation and data. Yes. I just like saying it's anything you can't touch. I think that's simpler. So, any questions on those guys right now? We'll be getting more into depth in each one of these concepts later on. This is pretty much the Hello World intro of all these items we need to get over and teach about them right now for people that are starting from 0 to hero. So this is your desktop. So that's what you're looking at right here. Hardware is the things you can touch. Software are the things that you can't touch. Monitors are the actual screen. Where's the computer picture? A monitor is in reference to the actual screen of your device. Why is some of these taking so long? So the actual device is the monitor. All right, you'll hear that term thrown around a lot. Then there's pixel. Pixels are the little tiny lights on your monitor that make up what exactly you can see. So if we type in pixel right here, these are the actual pixels that are on every screen in the world that exists today. Your monitor in front of you, if you're watching on your phone, it's on your phone. Now these are little tiny boxes. Can I zoom in here? So these don't really look like boxes. What it is the boxes are composed of three colors. The red color, the green color, and the blue color, right? All three of those make one pixel. That's what I refer to as the box. So you can individually, as a programmer, individually manipulate each one of those lights and change exactly how bright they are. We'll get into how you do that later, but that is what composes your entire monitor. So when people say your monitor is a certain resolution, each one of these boxes, the sets of 3 colors, is 1 pixel. So that's how many you have sets you have going height-wise and width-wise. All right. Any questions on that? All right. Let me check this other. All right, sweet. So let's get on to the next thing. Your CPU. People will throw this around a lot. You'll hear it in tech articles. If you know what a CPU is, you'll probably cringe all the time when people refer to them in tech articles or when people are on the news and talking about them. Super cringe because they'll use it wrong. CPU, it's an acronym. It stands for Central Processing Unit. What is that? Your computer, I want you to think of computers like the human body, all right? Humans and computers, we're a lot the same, all right? You know, right now they're being birthed with AI, and soon they'll be our brothers in arms that we'll be coexisting with. But we're really similar with them, all right? Each one can store information in our brain. Also, you can have short-term memories, which are in your brain. Also, you thinking is in your brain. All of them are in your brain, all right? But there's 3 different, separate things for computers. A CPU, which stands for Central Processing Unit. Yes, you do need to know that the whole name right there, Central Processing Unit. It's central to the whole system. It's required for it. It's central. Processing, it's thinking, and it's a unit because that's not, people that named it weren't really that creative, all right? Its whole job is to think. It's supposed to think about stuff and figure out what is what, all right? That's its whole job. That's what a CPU is. It's the thinker of your computer. All right, memory. People will say memory all the time, and they use it 100% wrong 90% of the time. All right, memory is not in reference to the storage capability of your computer. When you go buy a new iPhone and you see it has 128 gigs of storage, it's storage, not memory. Memory is your short-term memory if you're talking about humans. So short-term memory, maybe you remember things for a day, 3 days, 10 minutes, all right? That's what I do. I memorize things for 10 minutes, right? My short-term memory before it's gone. Memory is just like that for computers. It's short-term memory. It just lasts for a little bit. It's there for a little bit, and then it's gone. If you ever unplug your power from the memory of a computer, it's going to be completely gone. Memory is a broader term for something that's called RAM. Typically, RAM is random access memory. So if we look at memory sticks, so you'll see this a lot for computers. They'll talk about your RAM. If you're playing Minecraft, you might want to know what the recommended dedicated amount of RAM for your Minecraft server is. If you don't get the meme, I'm old. All right. So RAM, it looks like this. It's short-term memory. If the everything that you're doing, so right now I got Chrome open. Chrome open, this is in my computer's RAM right now. I have Discord open, Spotify, my computer is on. That means the operating system is in RAM right now. If I unplug the power, zoop, it's gone, all right? It doesn't have any recall for any of this stuff. So when I refer to memory, I'm referring to your RAM, all right? And that's about all that we'll get into for that. Now, storage. Storage is called storage, or your hard drive, or your solid state drive. This is your long-term memory. This will persist through any electricity being removed from the unit. This is saved and will be there when you turn on your computer again, just like your long-term memory. Your long-term memory is going to be there ideally forever, but sometimes you also forget your long-term memories. But that's what you think of when you're buying a new phone and it says 128 gigs of storage. That's your storage space. That's your solid state drive. That's your hard drive. We won't get into the big differences between hard drives and solid state drives right now, but just know the images of a hard drive, it looks like this typically. That's your long-term storage. It persists without electricity. All right. Now, just so we got through CPU, that's how you think. Memory, that's your short-term memory. Storage, that's your long-term storage, or hard drives, that's your long-term storage, all right? Next is GPU. Not all computers have a GPU. Some of them, well, a dedicated GPU. A lot of them have integrated GPUs. Don't worry about that. We'll get into that later, all right? GPU stands for Graphics Processing Unit. So CPU is Central Processing Unit. GPU is Graphical Processing Unit, or Graphics Processing Unit. They're pretty much exactly the same except for the first term. GPUs are meant for graphic and graphical data. That's what they're best at. Asterisks. We'll get into that more of that on another day. But GPUs are what help your computer render all the colors and beautiful things you see on your screen. Not all computers have a GPU or need a GPU. All right, that's the basics of hardware that we're going to go over right now. Are there any questions at all on hardware? Do I need to go over anything else? If there are no questions, then we're gonna go ahead and take a slight break. We're gonna just take I don't know, let's do like a 3-minute break. Everyone can get up, stretch a little bit, go yawn if you've been bored with me, go get some coffee if you need to stay awake through all this boring stuff. If I'm boring you, look, you're doing a bad job at telling me, because I don't see anything in the chat saying that. So as far as I'm concerned, you guys are just excited right now and definitely not bored. So so make sure you let me know what your thoughts are on everything. So 3-minute break, we'll get back and we're going to talk about operating systems. All right, let me do the transition thing. Whoops, oh god, so many transitions. There we go. I knew I'd get it right eventually. All right, 3 minutes, y'all. Dang. Alright, thanks for letting me know I was muted. Alright, so like I was saying, we'll wait another 30 seconds or so for anyone else who's just joining now from their break. Before going forward, look at this shirt. This shirt is the coolest shirt in the world, alright? Why? Because I helped make it, alright? That's why. And you can get yourself one of these shirts also by either going to our site and purchasing it, or better yet, you want to see that bar up, there we go, over there, fill up. If you donate on there, forget how much you need to donate, you'll be able to get a shirt for free, alright? We'll send you off one, we just need to know your shirt size. So if you donate now, you can get yourself one of these epic shirts. Also, talking about donating, the guy that donated earlier, I don't know what reward they claimed, but just in case it was dance time, we're gonna do a little dance, alright? Now, those that are younger, you may want to shield your eyes, because this is gonna be some painful stuff to watch, alright? Oh, not this song. I don't want to dance this. Also, for any of the emotes, the noises, etc., if you think they suck, which they're all the default ones, so they do kind of suck, alright? If you have suggestions, let us know what to use, put it in the Discord, and we'll switch off to those ones, alright? Alright, that's enough, alright? Stop torturing everyone. Alright, sweet. Thanks again for that donation. Alright, let's turn off the sponsor. Oh god, what have I done? The sponsor banner. Okay. Let's bring this back up. I know, I'm impressive. I should definitely not leave the computer programming space, alright? Okay, so we talked about shirts. We did our dance. Yeah, hey, another thing about our nonprofit, we're totally community based. We're community focused. So if you have thoughts, you have ideas, they matter, alright? Let us know whether it's something we should change on our stream, whether it's something I should change on how I'm teaching, whether it's something we should cover. You let us know and we'll do it, alright? We're all in this together. Oh my god. Keep it up. Alright, let's go. Oh my god. I hope you guys are entertained, alright? We're never gonna get through content if that goes off every every like 2-3 minutes. God, what was I saying? The community based. Your thoughts and ideas matter. Help us create, this nonprofit. Nonprofits are literally ran by the people for the people. No one owns a nonprofit. There are no stakes, ownerships, stock, anything like that. It's you guys. You guys are a part of the nonprofit. You're here participating. So this nonprofit is as much yours as it is mine. So let's make it better and let's reach more people and let's give people a good alternative that's known out there to college, so they don't have to use all their precious time and their money to go to college unless they really want to. Alright, let's see here. Operating systems. Oh god. Let's talk about operating systems. We're just talking about very light on top. Actually, I think there was one person asked difference between solid state drives and hard drives. We will get to that later. Don't worry. We'll go into those items more in depth on a later date. Right now is just simple hello world. Actually, programming. That's what we're supposed to do. So, if you're on a Chromebook, there's a website called Replit. I'll send this out onto the chat. You can use this site, and I don't know when they added this, but this is kind of cool. Look at that. You can use this site to program from a web browser, and it's pretty functionally complete. You can do a lot of things, and it's for pretty much every programming language that exists. So, or if you're on really bad hardware, you can use this, all right? Most of the time, any hardware is good as long as you have like Windows, but if you're on a Chromebook, or if you don't have a computer, if you have just a phone, you can program along on your phone using this, all right? All right, so operating systems. Let's talk about those a little bit. There are 3 major operating system groups. One is Windows, which pretty much dominates the user space world. So if you are a normal user, most likely you're on Windows and you're using Windows like how I am right now. Then there's Mac OS. That's the operating system made by Apple. All right, so if you have a Mac device, you're most likely using Mac OS. And then there is Linux-based OSs. So those are dominated by the server space. So if you're running a server, or you're accessing a website, or using any type of application that's website-based or has to connect to cloud infrastructure, most likely it's running on Linux. As a developer, you will need to know how to program on Linux devices and Windows devices. All right. Now, luckily for you, Linux and Mac OS are all based off of Unix. Don't read into that too much. So pretty much anything that you do on Linux and learn on Linux can be done on a Mac device. All right. Let's see. How do I make that loading background and logging effect? Not sure. I signed up yesterday and saw that, and I wanted to make my own. I'm kind of confused by the question. So, Jason, we can talk more since you are a Patreon member. All right. So, operating systems. Operating systems are it's the glue, basically. It's the glue that allows you as a programmer to interact with all of that hardware. Because by default, hardware is just a pile of expensive metal that's just sitting on the ground right beside you or on your table right beside you. It's pretty much useless. You can run electricity through it, but it's still pretty much useless until you get software that can tightly couple and figure out and make sense of what that hardware allows you to do. So that's what the operating system does, is it allows you to interact nicely with that hardware, so you can make sense and use it efficiently and powerfully. It also adds additional perks like users and management and etc. 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 We won't get into that too much right now, but just know the most important thing is an operating system is what allows you to operate the system that you are on, the hardware that you are on. And yeah, so be aware of that, because sometimes this is hyper optimization, but as you're building programs, sometimes it's the operating system that causes the biggest slowdown for your application. So that is something you do want to be aware of, because your operating system is literally what is interacting with the hardware. So just know that that's what drivers are for. So if you ever installed drivers or had issues with your drivers, those are specific pieces of software that work with your operating system to interact directly with that hardware. So sometimes it can be resolved with better drivers, but sometimes it's literally a mistake on the OS level. So you can blame Windows or Microsoft, or you can blame whatever Linux distro you're using or Apple for the issues. All right, let's go on to, so 3 major operating systems, all right? Windows, Mac OS, Linux. Android is Linux, all right? Mac OS, technically the iOS is built off the same kernel, so we're not going to get into that, but Mac OS, all right? All right, so starting today and going for the next couple of days, where's the me pull over Discord here. And this schedule right here is what we're going to be pretty much following. This is not a tight schedule. This is not like every day that's marked is exactly what we're going to be talking about, and that is it. It is up to the wind. If you ask questions, we'll talk about those questions. We might finish early, we might finish later. It depends on how you guys are soaking up the information. So ask questions, answer the questions that we ask, so I'm able to gauge where everyone's at. We're also tracking that, so people will be potentially rewarded for their interaction levels. And yeah, everything is fluid and up the air, all right? Nothing is predetermined. This is just the rough layout right now. Math. Let's talk about math, all right? Oh, just saw there was a comment. Wiggle room for requested topics. Yes, we are doing whatever, all right? If we take 1 to 2 days to re-go over stuff or talk about things that are on topic but maybe not exactly what we were going to talk about, completely fine. It is totally up to what you guys want for the next 100 days. Our base guide is just the computer science certification that we offer. All right. So, math. Everyone loves math, right? Everyone's favorite subject. It gets them energized. They have fond memories of math class and their math teachers and all the numbers. The numbers are great. Just lying. Everyone has terrible math experiences in grade school, all right? Maybe not all the time, but usually everyone has like a terrible experience. The thing is, math is a lie when it comes to computer science. It's not, you don't need to be good at math. There is technically math in it, but like, come on. It's like saying 2 plus 2 is like math and labeling that like as hard math, and now you need to know math to do 2 plus 2. Like, I have confidence that you guys know how to do basic addition, subtraction, multiplication, and division. And if that's ill-placed, look, just use a calculator, right? We ain't in school. You don't need to do this by hand anymore. Just use a calculator, right? That's what I do for 99% of it. Most of programming is logic. So as long as you can think logically, you'll be able to be an amazing programmer. This is not something that's easy for a lot of people right out of the gate. Now, I'm not talking about logically, like politically, like your aunt and uncle are fighting at Thanksgiving dinner or Christmas dinner or whatever, wherever they're fighting at some holiday event about the current politics, and you're not thinking logically about it. No. Completely different logic, all right? This is true logic. This is everything is true or false. There is no gray area. In the real world, everything is gray. There is no absolute truth. There is no absolute false for pretty much all topics. But in computer science, oh, it's easy. It's either one or the other. You have no in between, all right? It's super easy logic. It takes a while to get into the vibe, but it's literally just a vibe. I don't know how to explain it better than that, but as long as a vibe, a rhythm, after you practice it a couple times or program a little bit, you'll get into, your mindset will snap to it. It may take a week, it may take a month. When I first started programming, it took like, look, I'm a little slow, right? It took like 3 months before everything just snapped. And it just all made sense. It was like I went through the matrix and I took the pill and my mind was widened and opened up, right? Once you hit that snap point, it will all be just easy chilling from there on. But it's just you get into that vibe. And you'll see here in a second. So, logic, discrete structures, math. That's what we're going to be going over, is discrete structures, which is a topic that's covered in college. It sounds really, really fancy, but it's really simple. It looks like hieroglyphs, but don't worry, we're going to go through the hieroglyphs, but it's going to be super simple to discern. So we're going to go through some of this. So this is our Learn platform. So this is a lot of stuff we're going to be going through. We're going to start out with sets and relations. Trust me, this is going to be sounding like some fancy stuff. It's going to look fancy, but it's going to be very, very, very easy. Why do you need to know this stuff? Let's get into that for a little bit. Why? Why do I need to know this stuff? This is pretty much the fundamentals of logic. It looks fancy, complicated. Don't get overwhelmed. All right, don't read into it too much. All right, it's just a lot of PhDs making up symbols out their ass and throwing it on the screen, and this is what you get. All right, it's super simple. It's just addition for most of it and subtraction. This is important for you to understand logic. So in programming, from some of you guys that have done programming, you'll know there's things like if statements and while loops. In order for you to use those correctly, you need to logically think about the problem at hand. You know, if I want to make a program that allows me to make a shopping list, how do I go about that? This will help you with that logic. Also, all computers are made up of this fundamental logic. So we'll show you guys a little later on how this really intertwines nicely, but this is just about the foundations and the logic. It will be kind of confusing at first. I will try my hardest to relate it to real world things and programming as we go along. All right, sets and relations. This stuff, look, I hope this stuff scares you because I'm just kidding. It's not scary at all. Let's read this. Sets and relations are interconnected with each other. The relations define the relationship between two given sets. So let's take a second back and think about this a little bit. You couldn't have existed if there weren't two sets and a relation to make you, all right? A mother, a father, and a relationship to them. Maybe it was a little shady. Maybe it was a one-night stand. I don't know how some of you guys came out in this world. But there was a set, two sets, and a relation. That is pretty much all sets and relations are, is sets of things and how they're connected to each other. All right? This, complicated. All right? Mother, father, having children, simple. All right? We all understand that to a deep biological level. All right. So sets and relations are usually a term in dealing with mathematical items and discrete objects. And it will tell you whether those objects are separated from each other, or they're connected, or disjointed, or not connected, etc., etc., etc. So there's some terminology we need to know in regards to sets. Let's go ahead. So there's this thing called set theory, and it can test the efficiency of data structures. So how data is laid out, whether that's in your Excel spreadsheet, your PowerPoint presentation, whatever. It will tell you, set theory theoretically will tell you how efficient you're being, all right? We can use set theory right now to tell you guys how efficient I'm being right now. Probably not that efficient, but we'll figure out. There is a difference between sets for distinction and sets for counting. A set is an unordered list of items. This is important. I'm going to say it again. A set is an unordered list of items. So mathematically, programmatically, when we think about this, this is it. A set of unordered items. What is unordered? Unordered means there isn't one, two, like do this thing first, do this thing next. They're just kind of all listed there. So maybe you're going to the grocery store. You're making a list of unordered items. That grocery store list is, in mathematical sense, a set, all right? If you've made a grocery list before, if you made any type of list before without numbers besides them, you have been performing math. I know. You might as well put on your resume you're a math magician, because you've been doing math this whole time and you didn't even know it. So that's what a set is, unordered list of items. An element is an item in a set. So when you make your list of grocery items that you want to get, and you write on there that you want bacon because bacon is delicious, that is an element because it is a single item in the set. The set is your grocery list. All right, so individual items are called elements. Capital letters denote sets, lowercase letters denote elements of sets. This is the mathy stuff because math magicians, when they made this up, this is how creative they were. They said, hey, when I use capital letters, that means that thing is a set. When I say lowercase letters, that means it's an element of the set. It's an item of those sets. All right? There's a symbol also for element. This guy right here. I'm going to put this in the chat so you guys can look at it in amazement. Maybe be kind of scared of it. It's just a weird symbol that means something simple. If we're in normal English land, which people can understand, if I write the statement P is an element of A, notice how P is lowercase and A is uppercase. A means it's a set, P means it's an element, meaning P is one of the members of set A. It's written like this. So if you are feeling lazy, which look, if you're a lazy person, programming is the field for you. Math is the field for you. We're the laziest people you can find on the world, all right? We don't have time for writing, and this right here is how you write out this sentence. Now, this little too complicated, so let's think of this in a little bit of simpler terms here. Let's go ahead and pull up Google Drive. Let me pull this over here. Let me zoom in. We've been talking about too many, I don't know, terms that don't make sense. So let's go back to grocery list. Carrots. God knows you guys need some more vegetables in your diet, all right? Carrots are a part of my grocery list. All right? That makes sense. Now, replace that arrow that I did in there because they don't like arrows with the, gosh darn it, with the symbol I put. There we go. You can also write this out in English. Carrots are in the grocery list. Bam. That's literally what's happening right here. With this symbol. Does this make sense? Is anyone confused right now? Because I need you guys to be tracking this part before we can really move forward. I'm going to throw one more symbol at you guys. Just really confuse you guys hardcore. And it's going to be this symbol. Alright, it has a line through it. I'm going to go and paste this one in the chat too. This one, hopefully it's self-explanatory. It means it's not. It's not in there. It's the opposite. So if I copy the normal English version of this stuff, carrots are not in the grocery list. Any questions on this so far? Is this confusing at all to anyone? Now I'm going to see all you guys go on your Twitters, Facebooks, TikToks, XYZ and start using this on your stories. I don't see any questions, so we're going to keep moving on forward. Now, if you're watching this after the live stream, feel free to become a Patreon sub member or a Discord premium member, and you can post in the supported chat, and I can help answer your questions on these. All right, sweet. So we got over these two guys, in and not in. All right. So there's also one more thing. The members of all sets under investigation belonging to a larger set is called a universal set. The symbol for a universal set is a U that is italicized. There we go. What does this mean? U is everything else. That's literally it. It's everything else. So if my grocery list that I have it only has carrots on it, then things like beans and potatoes are not on the list. They're a part of the universal set because they exist They're things that are there, but they're not currently being used in any capacity. That's what the universal set is. All right. Let's go ahead and scroll down a little bit more. In geometry, a universal set could consist of all points in a plane. And here we go. This is a good example. In geometry, so I know that's a scary word, but let's go and skip over that word, all right? A universal set would consist of all points on a plane. So think of a map on a table, all right? Anywhere you could point your finger on there, that is a part of the universal set, because that's everything that you could potentially put your finger on. And now I realize this is also wrong. Carrots would be in here because this is all items. Sorry, universal set is all items. If you were on a map, you were doing a human population study, the universal set could consist of all the people in the world. All right. So if you're looking at a map, universal set would be everyone in the world. It's everything. For a given set of U, so when you use that special U sign, that's when you're referring to the universal set, aka everything. Property and a property, there is a possibility of having no elements of U that have property of F. For example, set S, all six-legged people in the human population has no elements, since no elements of U meet the requirements of property P. All right, let's talk about that a little bit. All right, a lot of stuff going on there. U is for universal set. Universal set is everything. So if we're doing a human population study on all humans in the world, our universal set is all humans in the world, because we're going to be studying all humans in the world. And we're going to call that variable U, right? Now, we want to know how many people, we want to make a subset from that of all the people in the world that have 6 legs. Well, there are no people in the world that have 6 legs, so that subset, P, would be empty. There would be nothing in it. Does that make sense? So let's move on. If there's nothing in a set, like a set of 6-legged human beings, you will call that an empty set with one of these mathy terms right here. So I'm going to go and grab these mathy terms and paste them here in the chat so you guys can see them. So if something is empty, then that set, and sets again are capital letters. So I'm going to say P is equal to this or that, because it's completely empty. So this first is, it's referred to as a null. Some of you guys that have done programming might know that term null. This is in reference to null, and this is in reference to null also, but this is just an empty list. We'll get into that a little bit more in a second. All right, if every element of a set is also an element of another set, then the original set is a subset of the other set. So it can also be said that A is contained in B, or that B contains A. The relationship is symbolically written as this. So let's go ahead and make some grocery lists. Grocery lists for Bob is, so we have the universal set, aka the grocery store. So this is where we're saying a lot of mathy terms, but they are actually like literally one-for-one real-world things that you're used to. Let's say the grocery store. All right, this is how you can figure out to optimize or perform the best grocery run in the world, is by using this type of logic. Universal set is the grocery store. In the grocery store, they sell, let's say, pizza, Cheetos, carrots and potatoes. There we go. And let's go ahead and make this an unordered list. Sweet. Bob wants to get pizza, but Alice wants to get Cheetos and pizza. All right. These are the grocery lists that we have for Bob and for Alice. Now, we can say, using this new math term that we got here, that A is contained in B. Bob, fancy math term, Alice. Bob's grocery list is contained inside of Alice's grocery list. All right? We're able to do that. Also, we're able to say that Bob's grocery list is contained at the grocery store, or also known as the universal set. So it's just a way for you to reference if your set is completely a part of another set, or they have all the same items that you do, which Bob has pizza, Alice also has pizza, and the grocery store also has pizza. Does that make sense? So same thing, if you do a slash through it, it means that they're not, the list isn't in that other one. So if we do Alice, that symbol, and Bob, we're saying that Alice's grocery list is not all inside of Bob's grocery list. So Cheetos is not inside of Bob's grocery list, so we would write it this way. That makes sense? Let's move on to the example they have right here. So we have, let's try some pro moves here and move out of nice term land and go and look at actual hardcore math land. U stands for universal set. So we have access to all of these numbers. These numbers we are allowed to work with. There's a set or a grocery list, however you want to think of it, called A. There's one called B and one called C. I know, very imaginative naming. These guys should get Nobel Prizes for these amazingly named sets or grocery lists, however you want to call them. You'll see each one of them has numbers that belong to them. Now, let's try to go through the logic here. For the sets above, C is inside of A and C is inside of B. Since 1 and 5 are elements of C and they're also inside of A and B. So if we look here, C has 1 and 5. There's also a 1 and 5 inside of B, and there's a 1 and 5 inside of A. So we can use those symbols to say that C is potentially a subset of, or is a subset of B and of A. All right? Now, we can say B is not a subset of A since some elements 2 and 7 do not belong to A. So B has numbers 2 and 7. So those are not a part of A, so B is not a subset of A. So that's where we would use this little special term to say B is not a subset of A. Makes sense so far? I know this doesn't seem incredibly useful right now. The point is, just doesn't make sense. I'm not looking for you guys to be masters at all this and kind of see the deeper meanings or anything like that. All I want you to be able to do is simply tell me, hey, is C a subset of something else or is it not? Any questions on that? All right, me see. Can you post the link from that site to follow along? This is a closed site. This is our learning site, which is currently closed to the public. So the answer is no for now. We are making a new site, mostly because we're transitioning away from this site. We are making a new one. So that hopefully will be launched in the next couple of months. It will have all this content rewritten to be more understandable and publicly posted for anyone to use and follow along with for learning. Because we're trying to make education as open and accessible as possible. Is it available for supporters? It used to be if you're a high tier supporter, so at the terabyte level, we can get you access to it. But trust me, you can just look back on to this video. Also, I'm going to be linking you guys videos of other people that explain it, so you can listen to how they explain it, and it will make more sense through them. All right, let's move on to the next properties of a set. So we got some new sets here. Every set A is a subset of the. Every set A is a subset of the universal set. U, since all elements of A belong to U. So this is pretty much saying the obvious thing that everything must belong in A, in U, which is God mode effectively, it's everything. And A is a part of U. The empty set is a subset of A, as given the value, but not listed. So empty sets are subsets of everything, because everything also contains nothing. Why? That's just how it is. Some things are better just not questioned and just accepted. Every set A is a subset of itself since the elements of A belong to A. So pretty much stating the obvious, yourself is equal to yourself. I am equal to I. A is equal to A. All right. Next, every element of set A belongs to set B. So if we look at that, 1 and 2 are inside of B, so that is true. And every element of set B belongs to set C. 1, 2, 3, 1, 2, 3. So this is great to point out. Order does not matter. If you want to get carrots first and potatoes later, cool. If your buddy wants to get potatoes first and carrots second, cool. You guys still have the same grocery list. It does not matter about order. And some more math stuff. So if B is a subset of C and C is a subset of B, then B and C have the same elements. So this is just mathematical proofing and just how you basically write down the rules of your math. So basically it's saying that if with this set, at any time you see logic anywhere that says that B, where's my symbol, is a subset of C, and then right after that you see the logic that C is a subset of V, then you know for a fact that B is equal to C, because this would not be possible unless they were identical to each other. So that's all that's saying, is if they're identical, you can say both this and this. If A is a subset of B, then it's possible that A is equal to B. So basically, it's saying that if you only have one of these, there's a chance they're exactly the same, that B and C are exactly the same. But you don't know for a fact unless this is also a thing also. So it's better understood if we start from an unknown point. So let's say you're trying to discover gold, All right, you're trying to become rich as shit. Now, you've figured out that the gold in this big area, aka your universal set, there is gold in this one area, in area, let's say A. And area A is inside of, or part of area A is inside of area B. Then you know that there's a possibility that area B might be actually identical to area A for your gold harvesting, and you might not have to send off 2 permits to the office to do mining on gold because you can just do it for A and not for plot B. But this is still up in the air because you don't know if they are exactly the same, because all you see is this, which says they might be. Until you see this, the logic that dictates this, then you know for a fact they are both the exact area of land. But if you don't see that, they could be, but they could not be. You don't know. You can't definitively say. All right, this is just basically saying that if you see one of the items, then they could be equal or they could not be equal. Then A is a proper subset of B. So now we're getting this term proper subset. Proper subset means that it is not exactly the same as another subset. So if we look at this one, A is a proper subset. So you could use this term, but this term is ambiguous in the sense that you don't know for a fact if they are the same sets or not. So when you use this new symbol, which doesn't have the underline, it's now a proper subset. It gets a little top hat and everything, and it starts talking in a fancy English accent. That is proper, right? Proper means that they're not the same, but A is a part of C. All right? So if we look at this list here, both A and B are both subsets of C, but A is the only proper subset because A is not equal to C. But B is exactly the same as C, they're just in different orders. So A is a proper, with the top hat and everything, subset. All right? Any questions on that? Is it possible to open relevant info during the week on the topic during Rootkit 100? Yeah, it would be possible. We'll talk more about it after stream and figure out how we want to go about that. But, all right. So, big things. Let's recap this. There's these things called sets. Sets are basically lists. All right. There's a universal set. A universal set is. Oh wait, hold on. Let me pull that up. Let's pull up the GitHub so you guys can see. I ain't lying. Let's move over here. Let's go over to basic math. And we're chunking through these items right now, right? We're on sets and relations. We just talked about universal sets. So if you want to do our exam, this is what you need to know. Universal sets. What are universal sets? Someone answer in the chat. Let's see if you guys have been paying attention. What is a universal set? Come on, anyone? Universal set. Perfect. I'll take that answer. U. Oh, and I got another answer. A collection of distinct objects. Perfect. Those both will work. U is perfect. U is perfect, but U is the symbol that you use. Universal set starts with a U. So U is the typical symbol you use for universal set. Universal set is everything you can possibly be using, messing with, utilizing, that's available to you in the problem that you're solving. So if the problem that you're solving is going to the hardware store and you need to get tools, everything at the hardware store that you could buy tool-wise would be your universal set. It's everything that's available to you. It's the list of everything that is available to you. That is the universal set. If you understand that, bam, you'll pass that on the exam. Subset. Subset is a set of items that are either the same as the universal set or less than the universal set. So if I'm going to the grocery store has produce, let's say carrots, potatoes, XYZ, that would be a part of the universal set because that's everything I have available to me. If I grab some potatoes and some carrots, and the grocery store has more items, that's fine. I just created a subset. I just created a set of items that I want to buy, I want to purchase at the store. That is your subset. Subset is and it can be equal to the universal set size. So let's say I grab one of everything at the grocery store. Then I also have a subset. Even though the grocery store has all the same produce that's in my hands right now that I'm carrying out of the grocery store, it's still a subset. A proper subset is anything that's a subset and not equal to the to another set that you're comparing it to. So the grocery store, if I grab every item in the grocery store that's available, I do not have a proper subset. I have a subset, but it's not proper because I also have all the exact same items that the grocery store has. If I return one of those items, then I don't have all the items that the grocery store offers, so I would just have a normal subset, not a proper one, not the one with a top hat. All right, does that make sense? Any questions on that before we move on to these guys? This is important to know because it is the foundation of everything else moving forward. But try not to overthink of it. Like I said, grocery list, and it's pretty much how grocery lists compared to other grocery lists or shopping lists compared to other shopping lists. Just think of it as that way. Unfortunately, you have to know the proper term because it's math, so you need to know that, you know, the plus sign is called the plus sign. You need to know that a set is called a set, unfortunately, but that's effectively what it comes down to. If there are no questions or people that need clarifications, we're going to move forward. This is your last chance. Hold everyone up. Be selfish, all right? Because we're chugging forward. If you don't ask a question right now. All right, so let's move on here. All right, operations. We have pretty pictures now, all right? Pretty pictures that will make everything make a lot more sense. We just got out of all the word land, and now we get to look at picture land. The U. So, because people in the math field like making things very confusing, this is the symbol for a union operation. The union operation and the universal set symbol look exactly the same, except one is italicized. The universal set is italicized. Union is not italicized. So pay attention to that one, all right? You'll see here on this picture that U is U is italicized. Let me pull this up. There we go. U is italicized. U, italicized, universal set. So what's going on in this picture? This picture is showing universal set, which is the theoretical everything that exists. A is a subset, B is a subset, and that's all the items that are available are inside those sets right now. When you perform a union operation, basically you say, I want everything in both of them. So let's say you're at your job and you're the boss, all right? You're the boss of a big company, and you tell your employees to make lists of everything that need to be done around the office to like clean it up and stuff. So they give you your lists back. And now you want to make a master list of everything that needs to be done in the office to clean it up. Let's say your company is actually a little smaller. You only have 2 employees, right? So the 2 employees give you their list of chores that need to be done around the office to make it pristine, right? Employee 1 is called A, and employee 2 is called B. When you make this new master list that includes everything that's in A employees list and in B's employees list, you will be doing a union, aka using this symbol here, and you would be making a new set called C, aka the master set, the master list of chores that need to be done around the office. So if we look here, everything in gray is the stuff that's included in your new master set. So that is the answer to the problem. So just like 1 + 1 equals something, it would be 2. When someone says A union B equals, it would be equal to everything that's inside of both A and inside of B. That makes sense? So this in programming, so if we were programming right now, this is where things start getting stitched together and start making a little bit more sense for those of you that have touch programming. This is what we refer to as an OR an OR statement. When you're doing logic, you would use the term OR. So you're making an if statement. If whatever the user's giving you as an input is in A or it's in B, it's covering that whole area. So think of it like that. It's the OR word. All right, this is a big programming word. So OR is union. Keep that in your head. OR is union. It's the exact same thing. So also in programming, we have things called ANDs, AND statements. AND statements would be upside down U's. Those are called intersections. So let's go ahead and paste that in here. And let's open up this picture and zoom into it. And is or intersections are for everything that's intersecting between 2 sets. So this, kind of easier to understand. Venn diagrams are the best way to visually see all these problems. If you have a set of A and a set of B, and there's some items that are similar, those are the intersecting items. So when you're doing an intersection intersection math, you're just getting the items that are the exact same. In programming, this would be the AND. So I would make an if statement in programming. If user input is equal to A and it's equal to B, this is the outcome you would get. Maybe it would be better if we also do some Python programming and show you the code side by side, just as a comparison. We won't get into Python programming just yet. So if you're not used to programming or syntax or anything like that, don't worry about it. We're just going to use it as also an additional visual aid. But first, we're going to go on another break. But before we go on break, are there any questions in regards to unions / or statements or intersections / and statements? No questions. All right, so when we come back from break, so we'll go on like another 3-ish minute break. When we come back from break, I'm gonna pull up and write some Python code. I'm gonna make an actual workable application that takes input from users, and we're going to mess with it and show how this math is what runs that, and how it's a lot easier than you might be thinking it is right now if you are caught up on this stuff. All right? Sounds good? During break, if you have questions, go ahead and drop them in the chat, and I'll review them when we come back. But let's take a break. Alrighty, we are back. Alright. So, we're going to take a look at this stuff with some programming aid here on the side, just to triple thousandly enforce all the things that are happening right now. So we got a basic little program here. Don't worry about the code. It's not really about the code part too much. Or if you don't understand parts of the code, don't worry about that too much. Just know that our program is going to want us to give it a letter. We're going to type a letter, and we have two sets here. We have set that has A, B, and C in it. Another set that has Z, X, and Y in it. And it will tell us if the letter we gave it is inside of these guys or not inside of these guys. Now, our logic right here in our if statement, which is exactly what we're doing right now with these Venn diagrams, is if the user's input, aka what I told the computer, which is the one letter I'm telling it, is inside, so if the user's input is in set A, so if it's either A, B, or C, or the user input is inside of set B, which is the X, Y, Z. So if I run this program right now, I can give it a letter. Let's say letter A. A, and it outputs, is in this set. Perfect. If we rerun this again and I give it the letter T, it will say it's not in the set. So just showing off, this is how you would do it programmatically wise. And then there's an AND. AND is the intersection. Now you guys might notice if we run this program again and I type in A, it will say A is not in the set. So what's going on here? When we did the or the union, anything that we typed in both either A, set A or set B, aka either of these guys, would give us a, hey, you did it, it's in there. But now that we're doing AND, it's only the intersecting items. And you'll see, if we look at these have no intersecting items. There is no similarity between them, between both of them, because one has A, B, and C, and one has Z, X, and Y. There's nothing similar, so no matter what we type, we're always going to be told it's not in the new set that we're trying to, like, quote-unquote, make. But if I throw in something that's similar, let's say J, into both of them, now if I rerun this and type in J, it will give us a positive prompt that it's in the set, because they're both intersecting, they're both in AND, they're both in intersection, aka upside down U. So how I like to think of it is U is you and us together, or however that song goes, or U as in union. Union is we're becoming one. Or, so ors becoming one, everything's included. Upside down U, it's like the satanic stuff, it's the opposite, all right? It's the exact opposite of what it normally stands for. So it's not about togetherness, it's about the basic things we have in common, what we intersect at. All right, if we look through here, intersection, union, next two items. So as long as you know what those are, you'll be good. You don't need to be a pro at them. You just need to know, what they are and the basics of what they do. All right. What if only B and not A? Oh, we'll get into that. Don't worry. We'll get into that later. We're not done going through all these guys right now. There is absolute complement. I said that right? Yeah. Or just normal complement, however you want to say it, which is set A is a set of elements which do not belong to you, but do not belong to, which belong to you but do not belong to A. So denoted like this. So it's basically everything that's not a part of you. Everything else that's potentially possible in the world. Just not yourself. Just not you. So let's go back here to our program example. We only need one set for this, so don't worry about B. We're just going to be focusing on A. And what we're going to do is we're going to say if user's input is not in my set A. So as long as we give this thing a letter that's not inside of this set A, aka ABC, we're good. That is an absolute complement. So if I give it a letter A, it's gonna say not in this set, like wrong. That doesn't exist. But if we give it a H, it will say we're good. That's in the set. Because our universal set in this case would be anything that's any letter that's typeable. So it's everything that's not in the set that is listed here. So everything that's not in A. Any questions on that? All right, next one. Relative complement. The exact opposite of the absolute complement. The relative complement or set difference of sets A and B is all sets of all elements in A that are not in B. This is denoted by the division sign or subtraction sign. So this is basically subtraction. So, 2 minus 2 is 0. So A minus B. So basically anything that belongs to another set, take that, scoop it out of yours. It's not allowed to be inside of your new set. So everything that's not shared. This is just someone that wants to just be away, alone in their corner, and not ever have any type of similarities with you ever, right? They want to be completely different at all times. This is, you can call this the hipster complement, all right? They want to be hipster. They want to be a hipster. They want to be someone that's different. You don't know me. All right. Any questions on that? So programmatically, we would write that user's input is in set A. So it has to be in set A, but it's not, but it can't be a part of set B. And user's input is not in my set B. So let's put something that's shared into both. Let's do H again, or let's put H in both of them. And now let's run this guy. So if we do the letter H, it says no, no, no. Even though it's shared, it's not in our new set. But if I do A, it likes it. It will take it. Any questions with that? All right, symmetric difference. Another cool little symbol. Let me put this in here. All right, symmetric difference is basically everything that is unique but not shared. So symmetric differences, everything that's unique and not shared. All right, that is the most important thing, and the picture fortifies it. It's everything that exists between two sets, but not the shared items. They are not included. They're not allowed to be in there. Does that make sense right now? Any questions on that? So we went through all of these guys. So again, let's do a review. Union is a U. Union means everything. Everything's being united in together, and you're making that new set. So if we were to write that out, it would be this. Our new set is equal to, let's do it this way. Our new set is equal to everything inside of A and everything that's inside of B. All right? That's a union. Intersection means that it's just the things that intersect. And that's done with an upside down U because it's the opposite of union. Let me go in and grab that. A, B equals C. So our new set is everything that's the intersection of everything. Now, stick along. I'm about to blow your guys' mind here after I review the last couple of these, which should take away most of the anxiety. So absolute complement. That is going to be, where's our symbol for it? It's going to be the careted or the power of. So A power of C equals, just do that so it looks different, is going to be equal to C. So this is everything that's not in A. Relative complement. That's the minus sign. And that's going to be everything that is, this is the minus sign. So A minus B equals C. So it's everything that's unique about B and not shared at all with C. And then we have our final one, which is the symmetric difference, which is everything that's shared between two items, but not the items that are similar between the two. So, thing that will blow your mind. Our exam is completely open book. That's right, completely open book. You can Google things, you can try to figure things out, searching, etc., etc., etc. It is 100% completely fine. You can have notes, notebooks, etc., etc. to do the test. That is 100% fine. Just make sure you know the items because the time limit is set very fast. So you will need to crank through them quickly. So if it's the first time you're learning a subject, you won't pass. You need to at least know the basics of something. So if you are looking through your notes, you can figure it out quickly and move quickly through it. But it is 100% open book. All right, you're not going to be locked in a room and given no access to anything. You can take the test completely remotely from your home on your computer and have as many aids as you want. Are there any questions on that? Epic. Let's see here. I think that's about everything we're going to go through for this stream. We hit on a lot of stuff. We started getting into the math, but as you can see, it's not really math. You can draw pictures and pretty much figure it out from there. These are all items that are listed right here. So if you want to know one of these items, we set up our guide here to be easily Googleable. So if you grab one of these items that you don't remember what they are exactly, you open a new tab and you paste it. There you go. You'll get your answer. You'll get the Wikipedia and you can look up stuff via there. Also, we have YouTube videos, which I will post right now into the chat, that you guys can watch, that will cover basically the exact same thing. So let's go ahead and grab this, and I'll put this in both chats. I'm gonna grab this one and put it in both chats, and I'm gonna grab this one and put it in both chats. So those 3 different videos talking about pretty much all the topics that we went over here, that will really help you guys out if you want some further clarification on any of those items. But again, super easy. You can copy and paste this stuff and get Google results for each one of those items. This is set up for you to be able to do at your own pace. We can't access those pages without logging in. Correct. For right now, we'll chat and figure out whether we want to make it fully open or not. Mostly because it's we want to rewrite a lot of it, so it's a lot easier to understand. And the plan was to do that after we're done finishing our new platform, because we hate Moodle, which is what it's on right now. Saying the links you sent me are inaccessible. Okay, you're right, because I messed up. My bad, y'all. Give me 1 second. I didn't send you guys the YouTube links.
This video went.
There we go. YouTube link 1.
Welcome to the screen.
YouTube link 2. And YouTube link 3.
This video will cover 7.
I'm going to post this on YouTube side. Epic, epic, epic. All right, so those videos are out. What questions do you guys have? This is pretty much just chilling Q&A time. Any questions you guys have in general over any of this stuff outside of what we've talked about? Just anything in general. Trust me, we're front loading all of the painful stuff so we can enjoy the nice fun stuff later on. But this stuff, don't worry. You'll get it. We'll get through it together. I believe in you. How far are you getting through today? This is, I think this is pretty much the stopping point I think we'll do for right now, unless you guys really want me to keep going forward. I think this is a pretty decent stopping point. I do have here potentially a challenge to give you guys. I'll look through it in just a second, so that way you guys can mess with it afterwards. That is always easy. This website lists many. Alright, yeah, we're going to go through this. So, unless you guys want us to keep moving forward, how much is left in this book anyways? Yeah. So unless you guys want me to keep forward, I won't be going forward, but I'll leave you guys with this challenge. This is totally up to you on whether you want to do it or not. It's pretty easy, and this will help you fortify this information so you can really get this and understand it right now. But let's go through it. Math is always easy until some jerk adds letters to it. And we're those jerks. This may be overwhelming to some of you, but trust us when we say we know you can figure this out. We are always on standby in the Discord channel if you need help or further explanation. This website lists many examples of how discrete mathematics are used in the real world. Research 2 topics of your choice and, in your own words, explain how discrete mathematics are being used in those applications. So, in your own time, you can look at this site. I'll go ahead and put this into the chat. But you can see some examples here. I also showed some examples on the programming that we did of how it's used actually in your programs. But just so you know, like, this is a thing that's important. You'll see the bigger picture as we go forward. But just research it and fortify your knowledge a little bit. And again, it's best to think about pictures. I like pictures. think about it as pictures. Draw pictures if that will help you. Draw pictures everywhere and fortify your knowledge on this stuff. Any other questions? What do we got? Give me on anything. Oh god. It spilt all over me. Mountains leave. I know you said be switching platforms. Possible. Alright, you guys. So tomorrow we'll be continuing at the same time, about 1 p.m. Then the next couple of days will be different times because I have some stuff that's going on, so probably be later in the afternoon here. And then next week Taylor will be teaching for most of the days because I'm going to be gone, so he'll be taking over your guys' introduction to computer hardware and all the ins and outs of that stuff. If you feel like this time that we're streaming at is inconvenient and think that a different time would be better, let us know in the chat, let us know on Discord. We can totally adjust the time that we stream as long as the majority of people that are watching stream agree that a different time would be better. This is not fixed at all, so it's totally up to you guys. If there are no other questions, then we're gonna go ahead and wrap up everything. This is all gonna be saved on the YouTube channel, so you guys can rewatch and fast forward through there. Also, we have our video editor on standby who will be over the next couple of weeks chopping up these live sessions into smaller couple-minute YouTube videos, so that way they're easier to digest for each topic. If you are interested in helping do the video editing, or you know someone that is good at video editing, we are open to more video editors, so just send them our way. Just let us know on the Discord, just ping us. Alright, last chance to ask some questions. Now, thank you guys for joining, and we'll be live tomorrow. I'm just gonna sit here for like another minute, just in case anyone else has anything else to say. All right, you guys. Y'all have a good one. I'll see you guys tomorrow.